How does Bluetooth work? A complete breakdown. 1. Introduction. Have you ever wondered how Bluetooth connects devices without the need for wires? Bluetooth has become an integral part of everyday electronics. From smartphones and wireless headphones to computers and a wide range of other devices. Most of us use Bluetooth daily without thinking about how it functions. Whether it's connecting your headphones to your phone, transferring data between devices, or controlling smart devices in your home, Bluetooth has revolutionized the way we interact with technology. In this video, we'll dive into the details of how Bluetooth operates, from radio waves to complex technical principles, hoping you understand the convenience and efficiency that Bluetooth brings to our modern world. 2. What is Bluetooth? Bluetooth is a wireless technology that allows devices to communicate over short distances, typically under 100 meters, using radio waves. It was first developed in 1994 by Ericsson, a Swedish telecommunications company, and was originally envisioned as a way to replace wired connections between devices like mobile phones and laptops. Since then, Bluetooth has evolved into a global standard for wireless communication, used in countless applications from wireless headphones and speakers to smart home devices, wearables, and automotive systems. The evolution of Bluetooth has been marked by several important milestones and version upgrades. The initial version, Bluetooth 1.0, was introduced in 1999 and offered basic functionality for simple wireless communication. However, it faced several limitations, such as compatibility issues and slower data transfer rates. Over time, Bluetooth technology has become faster, more reliable, and capable of supporting a wider range of devices. Bluetooth 2.0, released in 2004, introduced enhanced data rate (EDR) technology, which improved the data transfer speed to up to 3 megabits per second. Bluetooth 3.0, launched in 2009, brought the ability to combine Bluetooth with Wi-Fi for even faster data transfer. The introduction of Bluetooth 4.0 in 2010 brought significant improvements in power efficiency and introduced the Bluetooth Low Energy (BLE) protocol, which became a game-changer for wearable devices and IoT, Internet of Things, applications. The latest versions, Bluetooth 5.0, released in 2016, and Bluetooth 5.2, released in 2020, further enhance the technology's capabilities. Bluetooth 5.0 increased range, speed, and data broadcast capacity, allowing for better performance in environments with many connected devices. Bluetooth 5.2, on the other hand, introduced new features like LA Audio, which improves audio streaming quality, and multi-stream audio, which allows for better connectivity between multiple audio devices. With each new version, Bluetooth continues to improve, expanding its use cases and enabling more efficient and reliable wireless communication across a wide variety of industries and consumer products. 3. Basic working principle of Bluetooth. Bluetooth uses radio waves to send and receive data between devices. These radio waves are a form of electromagnetic radiation, much like the signals used in traditional radio broadcasts. The data that is exchanged between Bluetooth devices, such as your phone and wireless headphones, is represented in binary form, ones and zeros. These binary bits are encoded and transmitted as radio signals, which are then decoded by the receiving device to reconstruct the original data. For example, when you stream music to Bluetooth headphones, your smartphone takes the audio data, converts it into binary bits, ones and zeros, and encodes these bits into a radio signal. The radio wave essentially carries these ones and zeros through the air, transmitting them to your headphones. Once the signal reaches the headphones, the radio waves are decoded back into the original audio data, which is then turned into sound by the headphone's speaker. 4. Bluetooth frequency and wavelength. Bluetooth operates in the 2.4 GHz frequency range, specifically between 2.4 GHz and 2.4835 GHz. A part of the globally available unlicensed radio spectrum, this frequency range is commonly used by many wireless technologies due to its ability to provide adequate range while avoiding the complexities of licensed spectrum bands. The choice of the 2.4 GHz band is particularly advantageous because it offers a balance between range, power consumption, and data transmission speed, making it ideal for short-range wireless communication. The radio waves used by Bluetooth have a wavelength of approximately 123 mm, corresponding to a frequency of 2.4 GHz. The wavelength plays a crucial role in the propagation and signal quality. With a relatively short wavelength, Bluetooth signals are capable of traveling through the air efficiently, ensuring that devices can maintain stable connections over short distances, typically up to 100 meters, depending on the specific Bluetooth version and environmental factors. One of the key reasons for selecting the 2.4 GHz band is its widespread availability and low interference from other common electronic devices. The 2.4 GHz frequency is shared by several other technologies, such as Wi-Fi, cordless phones, and microwave ovens. However, Bluetooth has been designed to work well within this crowded spectrum by employing techniques like frequency hopping, which helps mitigate interference from other devices operating on the same band. Additionally, Bluetooth's relatively low power consumption helps prevent it from causing significant interference to other devices in the vicinity. The 2.4 GHz frequency range also offers a good balance between range and data throughput, making it suitable for a wide range of applications, from connecting wireless headphones to exchanging data between smartphones and other peripheral devices. Overall, Bluetooth's choice of the 2.4 GHz frequency range is a key factor in its success as a global standard for short-range wireless communication, providing reliable and efficient connectivity in both personal and industrial applications. 5. Frequency hopping. Frequency hopping is a key technique that Bluetooth uses to ensure stable and interference-free communication. In essence, it involves rapidly switching the transmission frequency over a set of predetermined channels. Bluetooth operates in the 2.4 GHz frequency band, which is shared by many other devices, such as Wi-Fi, microwave ovens, and cordless phones. To avoid signal interference from these devices, Bluetooth uses frequency hopping to transmit data across 79 different frequency channels within this range. This process helps to reduce the impact of interference and signal congestion, ensuring a smoother communication experience for Bluetooth-enabled devices. The primary reason for using frequency hopping is to minimize interference, since many wireless devices operate in the same 2.4 GHz spectrum. Signals can overlap, causing disruptions or degradation of the connection. By hopping between multiple frequencies, Bluetooth reduces the chances of persistent interference from other devices that might be transmitting on the same frequency. This makes Bluetooth highly resilient, even in environments with heavy wireless traffic, such as in homes or offices with numerous electronic gadgets. Bluetooth devices typically hop between frequencies around 1600 times per second, switching channels in a sequence that is determined by a pseudo-random pattern. This rapid switching allows Bluetooth to maintain a stable connection even when some frequencies are temporarily affected by interference. As a result, Bluetooth connections are much more reliable than they would be if the devices stayed fixed on a single frequency. The frequent changes in frequency ensure that the signal is continuously transmitted on a clearer channel, reducing the likelihood of dropped connections or slow data transfer speeds. The frequency hopping technique also plays a role in security. Since the Bluetooth signal is constantly changing frequencies, it becomes more difficult for potential eavesdroppers to intercept the data being transmitted. This makes Bluetooth a more secure communication method compared to other wireless technologies that might operate on a single, fixed frequency. 6. Signal modulation and encoding. Bluetooth relies on specific signal modulation techniques to encode data into radio waves, allowing devices to communicate wirelessly. The primary methods used are frequency shift keying, FSK, and phase shift keying, PSK. These modulation techniques enable Bluetooth devices to efficiently transmit binary data, ones and zeros, across radio waves while maintaining signal integrity and stability. Frequency shift keying, FSK. Frequency shift keying, FSK, is one of the most fundamental modulation techniques used in Bluetooth. In FSK, the data is encoded by shifting between two distinct frequencies to represent binary data. The presence of two different frequencies, one for binary 0 and another for binary 1, allows Bluetooth devices to transmit information over radio waves. The higher frequency typically represents a binary 1, while the lower frequency represents a binary 0. When data is transmitted, the Bluetooth signal switches between these two frequencies, creating a waveform that corresponds to the binary stream being sent. FSK is relatively simple to implement and effective at conveying data, making it a reliable choice for Bluetooth's low-power communication needs. The modulation process essentially converts the digital bits, 1s and 0s, into radio signals that can be sent wirelessly over the airwaves. Phase shift keying, PSK. In addition to FSK, Bluetooth also utilizes phase shift keying, PSK, to further enhance its communication capabilities. PSK encodes data by shifting the phase of the carrier signal, rather than altering its frequency. This technique involves changing the phase angle of the signal to represent different bits. For example, a phase shift of 180 degrees may indicate a binary 1, while 0 degrees could represent a binary 0. By varying the phase of the signal, Bluetooth can transmit data more efficiently, especially in environments with high levels of interference. One key advantage of PSK over FSK is its ability to optimize data transmission speed and signal stability. In environments where noise or interference might affect the signal, PSK is more resilient. The phase modulation helps Bluetooth signals maintain greater clarity and stability in noisy environments, ensuring reliable communication even in challenging conditions. This is particularly important in applications such as audio streaming or file transfers, where consistent and high-speed transmission is required. Combining FSK and PSK. Bluetooth combines FSK and PSK for optimal performance. FSK is typically used in lower data rate applications, such as basic data transfer, while PSK is employed for higher speed data communications and more complex tasks. The combination of these two modulation methods enables Bluetooth to be versatile and reliable, capable of supporting a wide range of devices and applications while maintaining low power consumption. 7. Bluetooth packet structure. The Bluetooth packet structure is essential for efficient data transmission between devices. Each Bluetooth packet consists of three main components: the access code, header, and payload. Access code, 72 bits. The access code is 72 bits long and identifies both the device and the packet. It ensures that Bluetooth devices can correctly identify and filter relevant packets, preventing interference in crowded environments. Different types of access codes are used depending on the context of communication. Header, 54 bits. The header contains 54 bits of control information about the packet. It includes the packet's type, length, and sequence numbers, which help the receiving device understand the data's structure. The header also includes error checking mechanisms to ensure the data's integrity. Payload, 500 bits. The payload is the actual data being transmitted, such as audio or files. It makes up the majority of the packet, with 500 bits of content. This section carries the real-world information that the devices are exchanging. Data transmission. Bluetooth packets are transmitted via radio waves. The access code, header, and payload are encoded and sent as a signal to the receiving device, which decodes the packet. Error detection, such as CRC, ensures data integrity by checking for transmission errors. 8. Conclusion. In conclusion, Bluetooth technology has revolutionized how we connect and communicate wirelessly between devices over short distances. From its origins as a simple means of communication to its widespread use in headphones, smartphones, and IoT devices, Bluetooth continues to evolve with each new version, offering faster speeds, greater range, and more features like multi-stream audio in Bluetooth 5.2. Its low energy consumption and ability to support a wide variety of devices make it a crucial part of modern life. As Bluetooth technology continues to improve, we can expect it to be even more integrated into our everyday activities. From smart homes to wearables. Stay tuned for more updates on Bluetooth's exciting advancements. And don't forget to like, subscribe, and hit the bell icon to stay up to date with our latest videos on tech innovations.